December 14th, vocabulary, dilations. A dilation is a change in size, but not a change in shape. To find scale factor, you divide new divided by old, and this little apostrophe is called a prime. We place a prime on the new measurements so that you know that those are the new measurements. A scale factor less than 1 will result in a reduction, which means the shape gets smaller. A scale factor of greater than 1 will relate in an enlargement, which means the shape will get bigger. And a scale factor equal to 1 means the shapes will remain congruent, or in other words, there will be no change to the original shape when you dilate to a scale factor of 1. So part 1, it says graph STU, triangle STU, with vertices at S, T, and U. S is at -1, 2, so I'm going to start at the origin. -1 means go left 1. +2 means go up 2. And I am going to label that as S. Point T is at 4, 0, so I'm going to start at the origin and go right 1, 2, 3, 4. And it stays on the axis. U means I don't go up or down. 0 means I don't go up or down. For U, I'm going to start at the origin. I'm going to go left 2 and up, or sorry, -4, so down 1, 2, 3, 4. And that is U. And so when I connect those points, I get triangle STU. It says dilate the figure using a scale factor of 1/2. Anytime they're given a scale factor, you take that scale factor and you multiply. So you're going to multiply 1/2 by every coordinate given to you for that shape. So we start with this first one for S. We do 1/2 times 1. Sorry, times -1. So half of -1 is -1/2. I'm going to have to resize that one a little bit. Okay. The next coordinate of S is 2, and half of 2 is 1. The first coordinate of T is 4, and half of 4 is 2. The second coordinate of T is 0, and half of 0 is 0. The first coordinate of U is -2. Half of -2 is -1. And the second coordinate of U is -4, and half of -4 is -2. So it says to graph the new figure, I'm going to take my vertices here, and I'm going to move them. The first point is now at -1/2, 1. So I'm going to go left just halfway and then up 1. Okay, that is my new S. So I'm going to write it this time with an S prime. Okay, and then T is now at 2, 0, so I start at the origin, and I go right 2, and I drop the new T there. I'm going to write next to it T prime. And the last point is -1, -2, so I'm going to start at the origin, go left 1, and down 2, and that is U prime. As you can see, this triangle is smaller. If you result in a smaller image, that is a reduction. The way that we state the transformation algebraically is we say we found half of x and half of y, or you can also change 1/2 to 0.5 if you wish. So we do 1/2 x, and I'm going to change the size of that so that it will fit. So it's 1/2 x, and then it's also 1/2 y. And what I'm going to do, I'm just going to copy and paste since it's the right size. And change the x to a y. So we basically divided this whole triangle in half. Each side is half as long as it was before. So that is example 1. We can go to the second page and look at example 2. It says graph triangle JKL with the following vertices. So we're going to take our vertices and we're going to say, okay, J is at -1, -1. So I'm going to go left 1 and down 1. And that's point J. Point K is at -2, 1. So I'm going to start at the origin. And I'm going to go left 2 and up 1. And that is point K. And then point L is at 1, 0. So I'm going to start the origin and go right 1. And that is point L. And this is triangle KJL. It says to dilate the figure using a scale factor of 2.5. So I'm going to take that 2.5 and I'm going to multiply by every single one. So 2.5 times -1 is -2.5. And then 2.5 times -1 again is -2.5. Okay, then we're going to look at K. 2.5 times -2 is -5. So we've multiplied 2.5 times -1, 2.5 times -2, 2.5 times 1 is 2.5. Two point five times 1 is 2.5, and 2.5 times 0 is 0. So this is 2.5, and this is 0. So we now have our new points to graph our new figure. And we already knew this was J, K, and L, and this was our triangle JKL. Now we're going to graph our new points with the new J, the new K, and the new L. So I'm going to take these blue dots. The first one is -2.5, -2.5. So I'm going to go left 2.5 and then down 2.5. And I won't be in a corner. I'm going to be right in the middle. And that is my new J, or J prime. K prime is at -5, +2.5. So I'm going to go left 1, 2, 3, 4, 5, and then up 2.5. 1, 2.5. That is my new K. And then L is at 2.50. So I'm going to go right 1, 2, and a half, and that is my L prime. So this is my dilated triangle JKL. And as you can see, the new one, which is the blue one with the primes, is bigger than the old one. So it is a reduction, I'm sorry, an enlargement. It is an enlargement. And algebraically, we multiplied 2.5x times y, and we multiplied 2.5x times x. So we did 2.5x, and we did 2.5y. Now we just gotta make it fit. Okay, so we have 2.5x and 2.5y. That means that we enlarged our triangle by 2.5. Okay, part 3 says find the scale factor of the figures. So if you pay attention to which one is your new and which one is your old, because the middle inside one has the prime, it's your new, and so the outside is your old. And remember, for scale factor, we do new over old. You can do this one of two ways. You can pick points on the graph and then compare your points on your graph as new over old. So for example, this point would be at 0, 2, and the old point was at 0, 1, 2, 3, 4. So I'm going to use the y coordinates. 2 over 4. 2 over 4 simplifies to 1/2. Another way to do this, if you have lines that run in straight up and down or straight side to side, they cannot be diagonal. If you have straight across or straight up and down lines, you can count the length of the lines. For example, this bottom on the new triangle is a length of 2, and on this old triangle, it's a length of 4. So your new over old would be 2 over 4, which is what we got earlier. So we already know that simplifies to 1/2. So the scale factor, no matter which way you do it, is 1/2. You know from the front page, if you have less than 1, so fractions and decimals are going to give you a reduction. And we're going to put scale factor is less than 1. I abbreviated scale factor to help it fit, or you can just make your text box bigger. Now it's 1/2, so I'm going to have to change my size some. I'm just going to do 0.5x. It's still not going to fit. Let's see how much bigger I can make my text box. Okay, so it's down to 6. And then we have to do 0.5y. So I'm going to make it the same. 0.5x, 0.5y, or you could have said 1/2 x, 1/2 y. It's just that we know 1/2, which is equal to 0.5, so I changed it to make it easier to type. You can do it either way. Okay, you do have an assignment today. If you have any questions, please contact your teacher.